Thanks for coming. Hi everyone, we are Gotan. We have created a mixed reality experience using Project Tango on a head-mounted display. I'm the co-producer Chuck.
I'm the game designer and artist Wei.
I'm also a game designer and one of the gameplay programmers, Nigel.
I'm the lead programmer, Cage.
And I'm a programmer and a co-producer, Vivek.
And we have two amazing, wonderful advisors, Carl and Tom. And we also have Carl Residel as our resourceful client. So our mission for this semester is to create an untethered mixed reality experience where users are encouraged to explore. The required platform from our client is the Project Tango on the head-mounted display. So for this project, we have four main goals. We need to try as best as we can to make people feel safe and comfortable when they walk around in the virtual space. It should be an untethered mixed reality experience. Intuitive and simple interaction is necessary. And unique playthrough that won't make people want to try it again and again in a different space. So what is Project Tango? Project Tango is actually a mobile device tablet that has motion tracking and depth sensing cameras in front, which gives you the ability to know where you are and how you move in a virtual space. Then we put on this Durovis Type 7 headset to give you the chance to immerse into the experience between virtual reality and augmented reality. We call it mixed reality. Our demographic is the early adopters, whoever has a Project Tango. And we believe that will be more and more people owns a Project Tango in the future. So we are going to share this on Google Play Store. Eventually, after 15 weeks, we have created mixed reality experience, mixed reality game, Garden. Let me show you the official trailer of Garden. So if you have a Project Tango and a headset, you just need to put the Tango in the headset and wear it on your head. And you are able to walk around in the virtual space wirelessly. Our system builds a virtual world based on the real world in front of you. And in this mixed reality experience, you can use your hands or feet to interact with the virtual object in the world. Just come and try it after the presentation, then you will know everything. Thank you.
So how did we get here? As for this experimental project, our design strategy is learning by doing. We developed a bunch of prototypes to test out our design decisions. So first we started to figure out our genre and then move on to the interaction design. Further on, we developed simple stories and simple levels built based upon it. So to take a full use of this motion tracking and depth perception technology, we managed to transform the real world into a virtual world in real time. And before quarters, we have 3 prototypes to try out with different directions, which Vivek will talk about later. And then we settled on this exploration framework, which encourages players to walk around in this virtual space. Then we move on to interaction design. We started with the gazing mechanic. However, it didn't really intuitive for players because they really want to use their hand in this immersive wireless VR world. But there are certain technical constraints we have to take into consideration. First, Tango can only detect objects from 0.5 meters to 4 meters. So for people like me, I have to play like this all the time, and that's why we encourage players to use props for extension or use their feet instead. Another constraint we need to take into consideration is our system will treat your hands as same as the rest of the world. So you will not see your real hand in this virtual world, you will only see the blocks you created. And that's why we designed this first prototype. We allow players to build platforms and for the virtual creatures to jump onto it. It's really interesting, but it turned out that we cannot really distinguish which blocks are created by players, which blocks are created by the environment. So players will feel they cannot fully control the AI pad. And then we move on to our second demo. For this demo, players can poke the virtual bushes and find a sheep hiding inside. and we give them a sheepdog as a metal detector. However, this metal detecting process is too complicated for new users to understand. And another thing is we didn't really explain why they cannot see their hand, but they can only see the blocks they created. So the poking mechanic is not very intuitive. Applied what we learned from the previous prototypes, we finally came up with this final design. Players can use the blocks they created to fill in the wireframes and draw objects into life. We themed this world as a garden, so players are encouraged to walk around, and they can kick off the path down in their garden and draw objects like plants to recover the garden. And for the item spawning, we also did a simple level design. So players are encouraged to have the good learning curve, and also every time it will be a unique playthrough. As for art, we started with very abstract art style, but it turned out that players will start to make assumptions if they feel confused. And then we settled on with this detailed 2D textures of this world, and make sure all the 3D art assets are pretty and low poly at the same time.
So when it came to player experience, there were lots of lessons that we got out of it. For one thing, we found that initially the experience was very jarring for players because they're dealing with the voxel creation going on in the world and at the same time trying to go through our game experience. So we found that making a pre-scan phase where the game experience doesn't start, we just allow the players to hold the tablet and walk around the room and see and make that connection between the physical world and the virtual world appearing on their tablet. And they can go at their own pace, and when they're ready, they'll be instructed to put on the headset and start the rest of the game experience. Another lesson that we found is that sometimes objects in our game can spawn in places that the player has already been, and they have no idea where they are. So we had very finely tuned 3D sound that first initially created the sound when the object first was generated. It had a sort of like beeping sonar type looping audio that would play to help them figure out where the objects were. Also from much of our iteration, we found play spaces that were not optimal for playing. Like for one thing, outdoors. The sunlight is filled with infrared light, and that messes with the infrared light sensors on the tablet. Similar kind of when the device looks at reflective surfaces like windows and mirrors, the infrared sensors don't work that well. And also we found that dim and featureless areas can cause a bit of a drifting effect on the Tango, so it's not recommended to play there. And finally, this is not meant for crowds at all. Too many people walking and moving around in the space has caused the environment to look very messy. But places that this does work in is like office spaces, places with high ceilings and lots of light, and you can even use this in your own homes or small apartments.
So for technical challenges, we had challenges both in rendering and spawning. For rendering, we wanted to run our game at 60 FPS for user comfort in VR, but at the same time we needed to support stereoscopic rendering and 3D scanning, which are both expensive operations. To meet these requirements, we use a voxel representation that's both cheap and easy to render. Alternatives like mesh generation using the margin cube algorithms will generate meshes that are not only more expensive, but will also be harder to partition and texture. Also, for rendering voxels, it usually makes the world look very flat. Adding shadows will of course help to make this feel to have more depth. However, shadows are very expensive in such a large and dynamic environment. However, ambient occlusion is actually very cheap with the voxel representation, and hence we use this to add additional depth and contrast to the world. For spawning game elements, we had problems before and after we spawned the game element. Before we spawn the game element, we need to know where we want to put the game element. However, we do not know about any details about the environment beforehand, or if any features in the environment will persist. But however, for gameplay, we want to spawn these game elements on tables and on floors. So what we did was we did feature recognition with the voxel representation, because this is very easy to do because it's just blocks. And we use this to detect flat surfaces at various heights, and we spawn our game elements there. Also, we didn't want to spawn our game elements too close because we wanted to encourage the player to walk around and explore. So we defined a minimum. However, we do not know how much available space the player has in his room. So we set a minimum distance for the items to spawn, and we slowly decrease this minimum distance when spawning keeps failing. Also, after we spawn the item, we have problems with the item like floating or being very under voxels, because the environment is always changing and the voxels are always changing around the element. To resolve this, we check for voxels within the element or beneath the element and adjust its position accordingly. For our interactable elements, we also had problems with the voxels prematurely triggering these elements. And for that, we stop this by preventing the item from being triggered when the player is far away. And if the player is near, we allow such triggering to happen. When the player is far away, however, we also detect for voxels within the element's collider, and we adjust the position of this element so that when the player eventually gets close, this element will not get prematurely triggered, and the player will have to use his hand to trigger the element itself.
All right, so we spoke a lot about how the project evolved and changed through the semester, but what we haven't told you is how, and the answer really is playtests. We've done a lot of playtests, 7 official playtests with over 50 playtesters and, throughout the semester, and what we were really looking for was very specific things for each of these playtests. And so in that way, we were able to test every part of our game through playtesting. So some of the things that we were looking for, like Wei mentioned before, was the genre. Like initially when we started, we didn't know which direction to go, and we just built a few prototypes in different genres and gave it out to players and saw what they wanted to play and what they felt most safe and comfortable in, and we found that exploration games worked great. So that's what we went with. Again, with interactions, we tried building platforms, having a separate object for the hand, but all of those things, because of the limitations of the hardware, wasn't working as well as we wanted it to. So we went with just filling in wireframes. That was really easy and intuitive for players. Again, with stories as well, we tried different things like have an extra pet that sort of guides you through the story, have portals that transport players from one world to another, but they weren't really working, so we just went directly with plain text, give them the instructions directly and immerse them into the world so they can do the exploration themselves. There were some other things we learned as well, like just by talking to playtesters after they were done. Like for example, some of them felt very uncomfortable without any other environment objects around them, so we put in extra environment objects. And the colors of voxels was sometimes confusing to players, so we made sure they were all in the same palette and they were subtle. And apart from playtesting, there were, I guess, some lessons just in terms of an experimental project itself that we learned. The first one is fail fast. So every time we had a new idea, we didn't just spend time discussing about it, we made a prototype and we gave it out to people, and that answered our question about whether it was working or not. Also, have a prototype ready all the time, so whenever someone walks into your space and wants to see what you're doing, you can show them something and you can get feedback from them. So we got a lot of extra unofficial playtests through this method. And about the game itself, we found that we don't really need to give players too much of interaction and story for them to enjoy the experience. We just let them into this interesting world and let them experience it at their own pace, especially new players. Many times they just wanted to go around exploring themselves, and though we do have interactions that they can do. So we've showcased this experience at a few events in San Francisco, and the feedback has been really positive. We've also submitted to a few conferences like the Unity Vision Summit and South by Southwest. So we're excited about that. So we were given this interesting platform that could do motion tracking and depth sensing really well. And we used that to create this exploration game. And we also added in interesting interactions and a simple storyline. And what we ended up with was an interesting untethered mixed reality experience that really hit on all the 4 goals that we had started out with. So we are Team Gotan, and we have created a mixed reality project using Project Tango. You can try out our experience after this presentation. We are now open for questions.
Thank you. We don't bite.
Yes, Jan.
I'm just curious why the tango must be upside down.
Yeah, so Jan's question is why should the tango be upside down? And the answer is that the Tango is, I guess, built to be held. The camera is slightly angled upwards. So if you keep it right side up, then it sort of like projects upwards. And but if you keep it the other way, then you can see the ground better, and it's just easier to walk. Yeah.
Have you measured the motion sickness or the effect of this on people with disabilities?
Right. So the question is, have you measured the effect of what this virtual reality on motion sickness for people? And what we found is that a lot of people actually find this more comfortable than, say, the Oculus Rift or other devices, because in this case you're actually moving in the real world, right? When you're moving in the virtual world, so there's no disconnect between the reality and the virtual world. So many people actually told us that they felt lesser sick in our experience. Yeah.
Oh, also we actually keep it higher than 60 FPS. We don't really keep it at 60 FPS. So we try as much as possible to give as little latency as possible when the player tries to move, so that he doesn't feel motion sick. For example, me and Chuck, we are both like really prone to motion sickness. So when we are constantly debugging and testing this game, we have to make sure like, oh, if we feel motion sick, oh, what's going wrong? What's my frame rate right now? Like, is it going like too low or something? Like, yeah, we always have to keep checking that. And we have to keep like feeling for ourselves whether we get motion sick.
And for design, we also chose this very slow-paced gameplay, and to avoid like the instant moving, and encourage them to take their time. And this game experience will last like from 5 to 10 minutes, so it's a very short experience. Yeah.
How much focus did you guys have to put on player safety with walking around in these environments, and what kind of things or fail-safe did you put in place for like the minimum range of the device, as well as like playing outside or something so it doesn't listen to you?
Right. So the question was, first of all, what do you do about player safety, and also about other things like going outside, playing outside. Well, first of all, we have a warning video that we play before the experience starts that sort of tells players a few of these things, like what they should do and what's good to do and what's not good to do. But also in the experience itself, since the world is being created exactly based on the real world, they sort of have some sense of where objects are. And we make sure that if there is an object, there will always be a voxel that represents that object. The problem with that is sometimes you might falsely detect something, but we'd rather have that than not put a voxel where there might be an object. So we sort of push it to that end. About using it outdoors, again, we have the video, and we just let them know clearly that, what's a good thing to do and what's not. Sorry.
Actually, it's absolutely empty when you walk outside, when you play outside, just nothing inside. So they don't know what to do. So when they go outside, just don't know what to do, then we'll come back inside again.
All right, one more question.
Yeah.
So I have a question regarding the spawning of objects. So are you spawning objects even if the user is not looking at them? Was that causing like calibration issues? Like later, if I'm looking somewhere else and I end up looking back, was the voxels the same as you have previously generated? Like how did you solve for that?
So the question is, when you're spawning objects, are you taking the user's orientation into account?
Well, we are, and we are also spawning objects when the player is not looking, because we already have a partially scanned area of the environment. Were you asking about like when you look at an object and then you look away and then look back again, whether it will like shift a bit?
Yeah.
Oh yeah, that actually does happen to some degree, but for the length of our gameplay, it doesn't actually it's not significant. But if you use it for a really long time, like about 20 minutes or half an hour, it will start becoming significant. Like you start to feel like your world is drifting away. Tango actually has some algorithms in place to stop this, but from what we have seen, it's not good enough. So we have tried several things several things like to like adjust it a bit maybe, but it still doesn't work for too long. Yeah.
Thank you.